let's do a little bit of a recap of where we are with our sampling distribution of the sample mean so far. So your first step when you're working with these averages is that you want to look at the population distribution and decide whether it's normal or not normal. So we haven't addressed what to do if your original population is not normal. That will be coming up really soon here in the next couple of videos. What we have talked about though is if your original population is normal, your sampling distribution will also be normal no matter what sample size you're using. And so you can proceed to use those formulas that we've been working with. So let's look at a couple of examples here. What you're going to do for each of these is you'll find either the population distribution or the sampling distribution. And then there are some questions to kind of help you work through those probabilities and see what's going on here. So the first one, Express Courier Service has found that the delivery time for packages is normally distributed with a mean of 14 and a standard deviation of 2 hours. And the other one is about interviews. The personnel office at a large electronics firm regularly schedules job interviews and maintains records of those interviews. From the past records, they found that the length of a first interview is normally distributed with a mean mu of 35 minutes and a standard deviation of 7 minutes. So what I'd like for you to do is go ahead and work on figuring out what those distributions are and use the Rossman Chance Normal Probability app to calculate those probabilities that are related to those. So if there is a link on the chapter 15 page that'll get you to Rossman Chance, as well as you can just Google it and it should come right up. All right, so let's go ahead and pause the video, give these a try. All right, so here we are in the Rossman Chance app, and hopefully you gave these a try. Let's look at the first one with the package deliveries. So if we select a single package at random, what we're talking about is the population distribution and the same kinds of ideas that we worked with in chapter 3. So our population distribution is going to be normal with a mean of 14 and a standard deviation of 2. So I'm going to go ahead and put those into the app here and scale to fit. And then they want to know the probability that that one package is going to be delivered in 15 hours or less. So I'll put 15 in for X. And then as I look at the picture, it's the left side that's shaded, which is the less than side. So that's exactly what I would expect. And that probability then is 0.6915 or 69%. Now, the next part of this problem says, if a simple random sample of 16 packages is selected, what is the sampling distribution of their mean delivery time? So it'll still be normal. The original was normal. This one stays normal. The original mean was 14, so the new mean is also 14. The only thing that's going to change here is our standard deviation. So we'll take the population standard deviation of 2, and we'll divide it by the square root of 16, our sample size. And that gives me 0.5 for my new standard deviation. So that answer to the first part, that sampling distribution is going to be a capital N for normal with the number 14 and 0.5. So all I'm going to do now in the app is I'm just going to change the standard deviation because everything else stayed the same. And I'll choose scale to fit again. And now I want the probability that the average length of delivery time for all 16 packages is 15 hours or less. And so that probability is 0.9772 or somewhere between 97 and 98%. So much more likely that we're going to get these 16 packages delivered in an average of 15 hours or less. Right, so the next one is about the job interviews. And so for a single person selected at random, they want to know our population distribution. So that'll be normal with a mean of 35 minutes and a standard deviation of 7 minutes. So I'm going to change these in the app. So mean is 35, standard deviation is 7, and scale to fit. And now we're looking for the probability that first interview is 40 minutes or more. So I need the right-hand side of the graph for or more. So I'll click that inequality sign and flip that over. And then I'm going to put in 40 for X. And so the probability that first interview for one person will last 40 minutes or more is 0.2375 or almost 24%. Now, if we have a simple random sample of 9 interviewees, the sampling distribution of their mean interview time means that I'm going to need to take that standard deviation of 7 and divide it by the square root of 9, which gives me 2.33. So the sampling distribution overall is going to be normal with a mean of 35 and a standard deviation of 2.33. And now we're interested in the probability that the average interview length for 9 people is 40 minutes or more. So again, the only thing I need to change here, because we're still dealing with that 40 minutes or more, is just the standard deviation. So I'll change that to 2.33 and scale to fit. And now that probability is 0.0159, or somewhere between 1 and 2%, about 1.5% of the time, that average interview for all 9 of those people will exceed 40 minutes.